So next is Jan, who is coming from Berlin. He works there with SoundCloud as a front-end developer. And a fun fact about him, he's actually into music not only with his work, but also in his private life. He has a JavaScript music band. I kind of tried to understand what that means, so he told me he's using the audio engine of the browser to do something, blah, 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 blah. But the point was, the name of the band is Nested Loops. So I think that means something. Right, so, okay, we need some time. Cool, what else can I say? Make a joke, not a dirty one. Sorry? Ah, yeah. How do you go to DevOps? Ne, I have to say this in Bulgarian. I don't know the English version of this. Okay. Как се влиза в офиса на DevOps? С крак. Защо? Защото ръцете винаги си пълни и носиш нещо. Подаръци. Аз им нося баница, между другото, и много се обичаме. Другата ми. Защо жената на сисадмина не трябва да работи? Защото никой няма да я пипне с пръст, ако работи. I'm out of jokes, guys, please.
We are working on it.
You're working on it.
Any DevOps guys here? I mean, our hands are full right now, kind of.
We can think of something. Woo! Ah, no, it's not over. Good. As I said, this is not a conf. Don't have any expectations. I'm making music already. JavaScript music in the browser. Ready? A round of applause for Jan. Woo!
Can you hear me now? Cool. Hey, I made it. So yeah, as you already said, I'm Jan. I'm the Deftone on Twitter, and I work at SoundCloud. Usually I talk about music. Not today, so you're at a React conference, so you don't get to hear any music. So I work for SoundCloud, which is this website and an app for creators. You can upload your music and you can listen to music, and it's a giant single-page application written in Backbone. We all love Backbone. It's still a great architecture. We have a very high velocity, but today I will actually talk about our Xbox application. This is a thing that we recently built in TypeScript, React, and Redux, and it's working very well for us. And I have to say, in order to understand most of this talk, you need to understand a bit of the basics of Redux. We had a talk before explaining this, but I'll just quickly go over it. Like, what you need to know is Redux puts all your application's state into one gigantic object, and then you like your components can request parts of that state, and that's how it's basically working. Let's get back to Xbox. Fun fact, it's super easy to build web-based Xbox applications. I can't talk about it now, but if you want to know about it more, I can definitely talk to you about it at dinner or something. But we have a problem. We have a really big problem, because our users use the app a lot. Like, they listen to a lot of songs, they like, they repost, they go to profiles, they use discovery features. They do that a lot. Also, they do that for a super long period of time. There are users that don't close the app for 2 weeks. Can you imagine you have like a tab open for 2 weeks, It's pretty horrible. And that's not an edge case. Like our power users do that, and I also do that because I have to test it. But yeah, that doesn't sound like a problem. Of course, like if you're into like business intelligence, this is great. Like people actually use the app and they like it. But as a software engineer, in terms of usage, this is a big problem because, oops, we keep adding and adding and adding and adding data to our Redux store. And if we map this, this is time, this is usage, it goes linear like this, hopefully only linear, and at some point it just explodes, and you see this. It's like, no, that's not what your users want to see. This is what happens in web. It doesn't happen anymore because we have systems now. But we had the same problem in the Xbox app, and that's even worse. So imagine you're playing your favorite game on the Xbox. You have your favorite SoundCloud playlist playing in like full blast, right? You're like totally in the game, totally listening to the music, and then in the background, the Xbox app, the SoundCloud app, gets killed because it's using too much memory. What happens is the sound from the game is coming at full blast all of a sudden, like, and you have no, like, you don't know about it that it's going to happen. It's just like boom in your face, and this is definitely something we don't want to have happen to our users. So what we essentially needed to do, we needed to find a way to release memory while the app was running. And how do you actually do that in JavaScript? Because it's a managed language. You can, of course, reload the page. It's like the easiest way. It's like, boom, gone. And that's actually a solution that a couple of websites use. One with a big F and a B, and it's like bluish. They do that. Don't know which one exactly it is. So you can add like heuristics to your app to determine how much memory am I using, how long is the session, and then whenever I click on a button to go to a profile or something, instead of doing it on like the single page app, I just do a full reload. It doesn't really matter. Like as a user, you don't notice. But if you use SoundCloud and you click somewhere and then you're listening to music and you click and it reloads and the music stops, you're like, ah, great SoundCloud, thank you. This is horrible. So we can't do this, sadly. So another way is you just set, you have like this gigantic state, you set it to null, and it's gone. This is also pretty bad because you have to refetch everything, and it's just a gigantic mess. It doesn't really work well with Redux. So we had to be more smart about this. So we had to find a way to release only parts of this gigantic object when we don't need it anymore. And this is where we all go back to university. So garbage collection is a very well-researched topic, and so there are already solutions for this problem, so we didn't even need to think about it that much. And it sounds very complex, and like people might be scared, but I promise you, you will understand the two basic concepts of garbage collection in this talk. First one, reference counting. So this is a simplified version of the problem. In reference counting, you have something like an entities accessor that has access to all your objects. It's like T1 to T5. They all have this little 1 there. That means somewhere in the app, they're used once. So what happens is your application needs an object. You're like, hey, give me an object T1. Entity says, oh, yeah, this is 1. So another person wants to use T1. So I increase the counter to 2. I return the object. Hey, here you go. You have T1. Really simple so far. Then that's when you request an object. But also you have to tell them when you don't need it anymore. So let's say a view gets out of, gets deleted. It has to say, okay, I don't need T1 and T2 anymore. So it's like entities accessor. Okay, decrease the counter, and we're done. And then at some point you start a garbage collection process. And it's like it looks at all the objects there, and if you have a 0 next to you, you're dead, and the memory is released. It's like I don't know. When I had this lecture in university, it was like 2 hours. And this is like 2 slides. This is what it actually does. It's very simplified, of course, but like you get the idea, I think. there's another concept, tracing. And it's a bit more complex, but I promise you will understand. Let's say we have our entities again. That's like the entity successor. And it's like divided in tracks and playlists for the sake of this example. And we have a playlist view that has a reference to a playlist, P1. And we have a play queue has a reference to 3 tracks. That means in our entity successor, we have 1 playlist and 5 tracks. You know, why do we have 5 tracks? Because objects can have references to other objects. So the playlist actually has a reference to these 2 other tracks. This is how it looks like. And a tracing garbage collector removes objects that are not referenced anymore. So if we go away from the playlist view, we look at it, okay, there's no reference to P1 anymore, it's removed. That means we remove P1, and because all the references from P1 to the other ones are gone, we remove these, we remove all those tracks, and then we end up with a clean state afterwards. And this is kind of like how tracing works. Quick like nodding, is this understandable? Nodding, or this is no and this is yes? Good. Cool. This is kind of how it works. And it's not that complicated when you have it in an animation, when you're not in a lecture. So this is divided into 2 steps. This is the marking step, and this is the sweeping step. So if you're ever in a quiz or something, this is like where you can use all that trivia. So what we did is we implemented a tracing garbage collector. We didn't go for counting because we didn't want to keep all that extra state of like how often did we reference this and like decrease the counter, increase the counter. And we saw like something that was similar in Redux to how tracing actually works. And if you look at this again, the thing on the left-hand side looks like your store, your entire state. And then these things, they totally look like your Redux selector functions. And we just had to find a way to get hold of all of these selector functions so that we can build a system to remove all the state from Redux that we don't need anymore. And I will show some code now, and I hope it will go well. So what we essentially had to do is, instead of using the regular connect, we had to build our own like framework around it and kind of wrap all our components in this other connect thing. So let's say this is our playlist component. I think it's like a regular React app. It just renders a playlist, has a normal connect. You're just selecting the playlist from the state. Nothing too crazy, I think. And now I will show you how the garbage collected version of this view looks like. It's the same, because the way we built the system was that the application developers don't actually have to think about a new concept here. They should write React components the way they're used to writing them. They should use Redux the way it's written. It shouldn't add like another layer on top. And now we're actually going to implement this system. That took me 2 weeks to write, and we'll do this in 5 slides. It's really simple, like this connect thingy, where you just break it down. So the connect thingy actually has the map state to props and the map dispatch to props, like you know from Redux, if you know Redux. We create a composed component, one that at first does the regular connecting. It's only doing what you would do normally with your component. We just connect, and then we compose it with another component where we add a lifecycle. And so what this does is it wraps your component in another component. Whenever your component mounts, we register that selector. We get a hold of it. Whenever it unmounts, we remove that selector. It's, again, hopefully understandable. And what does this actually mean? We have a global array in our app somewhere. It's not managed, very well managed state. And then when you want to add a selector, we just look, oh, does the selector already exist? It's like, if it's there, then we just update props and blah, 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 it doesn't really matter. But we just add it to the list of all our selectors. This is rather simple. And oh, I said simple. I shouldn't say simple, I learned today. And removing is the same, like you pass in an instance and say, okay, if I have a selector for this instance, just remove it, chuck it. We don't need it anymore. So what kind of is happening in the background? Your component mounts, you have a new selector for tracks, or you have a new selector for playlists, and when it unmounts, it just goes away again. And if we take this one step further and look at how our Redux state looks like in the end, we have this global thingy like clutched in somewhere in the global namespace. We have a list of selectors for the playlist, the P1, and we have a selector for the T1 and until T3. And now we unmount, this selector is gone. And then garbage collection is actually happening. When we garbage collect, so right now we have this gigantic state. We have this list of selectors. And what we do is we just execute every selector that we have, and then the result of these selections, we just merge them together, which will be our new state, which will mean, like if we had 100 tracks before, but we actually only need 5, like the selector will only return 5, and our new state will only have what the selectors are requesting. So if you look at tracing again, tracing before was like, okay, you take things out that you don't need. What we do is kind of the opposite. We only add things that we need. And it's like this, okay, like in our app.js, app.jsx, app.tsx actually, we simply define an interval when we want to GC. GC is only sending an action to our Redux store. Yes. You can come up with a more sophisticated way of finding out when you actually garbage collect, like how long your application is running, or how much memory you're consuming. But like this is only like every 10 seconds, or hopefully 10 minutes. Don't do it 10 seconds. We run this. And what this does is like this is our big like main reducer. Like we have like this combined reducers, we're just doing like all the business logic. And we have this thing around. It's like, okay, if the action that comes in is a garbage collection action, just run this special reducer. And this is where all the magic is happening. And you will be so disappointed because there's actually no magic, and this is all that is. Because this thing is just literally running over all reducers and merging the result of all the selector functions into a new object, and your entire state gets then you will have rebuilt your entire state. And I'm sorry it's so disappointing. It's only 5 lines of code for garbage collecting. I tried to make it longer, but no. Yeah. So what happens is we at this base, like we're garbage collecting. We have only one selector at the moment. That means, oh yeah, only one selector. That means our entities, which is kind of like our Redux state, is clean again. And this is our memory usage afterwards. Like at any given point, we garbage collect, like we don't crash anymore because of memory leaks, and the world is fine, you would think. Let me give you some context on like efficiency. It's a really efficient system. Like if you have doubts about this, is because it's only running things that are already visible to the user. Like all these components actually all do work while they're visible, and we don't iterate over things that are unnecessary. Components are also not re-rendered when garbage collection is happening, because your selector is just selecting something that was already there and it has the same reference. So that's the same, and garbage collection should happen very rarely anyways, so you don't need to run this every 10 seconds, only when you need it. There's some disadvantages, because you actually need to run all your selectors again. So if your selectors have a lot of logic in them, that's bad, because it will make it, like the garbage collection will actually take a lot of time. But also you should not put a lot of logic into selectors anyways. They should be simple. So it shouldn't be a disadvantage, but I just put it up here so you're aware. Keep your selectors lean. And you need some additional metadata. I was kind of lying to you of saying like, oh, this reducer around is so simple. You do need to tweak it a bit to make it work. Like you have to agree, like your selectors and your reducer, they need to agree on like a format of how you can merge this state. And this is something that I couldn't put in here because it's something that is inherently encoded within how your application works, how you structure this for yourself. Which is also the reason why I don't make this open source, because this is something that you can build onto your own application, but then where it comes to merging, you can decide it for yourself, like how to do that. And I also don't think I could maintain an open source project so well. That's another problem. Disclaimer, so I said I simplified some things. You might, like if you want to implement this, then you need to reiterate again the selection format, and I'm happy to talk about more complex, like if you ran into some problems like this, I'm really happy to talk about it in a break. And the final warning, you might not need this. This might look so cool, your Redux state is going to be so efficient, it's going to be so amazing. Please don't do this, really. First identify that memory is actually a problem in your application, because at the end of the day, there's quite some architectural overhead that you have from this framework that you don't really want to have. And if you don't really have this problem, what you will end up with is just like the most beautiful bike shed that you ever built, and it doesn't actually give you anything. And if you don't want to listen to me, you can listen to Dan Abramov, because he replied to a user asking about garbage collection. The user was asking, should I go with the approach and worry about garbage collection later? Dan says, yes, worry about it later, when you actually have that problem. And that's it from me. Thank you. This was fast. Oh, no.
Yeah, thanks, Jan.
I hope it wasn't too fast to understand. Happy to answer questions.
Now we will have a longer panel, so we will have questions. So this time, a new addition, Chao is joining the panel.
Oh, no.
I think he has some questions. So,
why do they look so happy?
They're like, oh. Anyway, I'm really looking forward for this interesting discussion. Who wants to start?
The host. Okay.
Dear host.
Yeah, so actually, how do you handle, do you handle the garbage collection during server-side rendering, or you don't worry about server-side rendering?
We don't do any server-side rendering.
Oh, you're so lucky.
Yeah. Well, we have this problem of not having a server at all and have everything on the client. That's another thing you don't really want to be into as well. It's like, oh, long-running applications are a big pain as well. Trust me.
Yeah, and I guess like your app runs on Xbox, but for example, I can imagine this be a problem with a mobile app or like a mobile player if you move to something like React Native, where you also have the same issue of garbage collection, because mobile apps can be, especially music apps, always run in the background.
Mm-hmm. I have never thought about it. It could, like, are you concerned about the runtime of the garbage collection, or?
No, I think the solution of having like this manual garbage collecting through your Redux state will be very useful when you do like a mobile app, for example, a mobile audio player app, because for example, with Spotify and it's live like 4 hours, 5 hours a day, and it's always running, always streaming. And you, if they did the regular approach, not the approach you have with cleaning up your the mess you made, then the RAM actually gets like and then down because the app crashes. Yeah.
Yeah. Luckily, these platforms usually have like their own garbage collection built in, and like if you don't capture your garbage in Redux like everybody else does on the web, so yeah.
I was wondering while I was listening, aren't you actually going around the design limitation of Redux?
The what?
Aren't you going around the design limitation of Redux, of the general library and pattern?
In what way?
Well, in a way that you actually have to manually do garbage collection.
I don't think we're going like around the way Redux is intended to use. Is that your question?
Yeah, maybe is there a better way to actually implement this if you're not using Redux at all?
Yes, definitely. Like, if we like Redux because we have a lot of shared components and like a lot of shared code where we can reuse components across multiple platforms. So we decided for Redux as a state management. But if we wouldn't have used Redux, this would have been a very, we would have solved this in a very different way. Yeah, like this was, Redux was limiting us so that we had to go this far because we have this gigantic blob of data lying around.
Also, I was wondering, and one of the reasons why we didn't go with Redux in general is that it introduces coupling between your components with the selectors. So it's kind of contract between all the components, and all the components know about those contracts by name, basically. This is how you can merge them. Otherwise, you cannot merge them.
I think, so the way we solve this is we have abstraction, like components that abstract all that, like fetching, selecting. We abstract these out so that when you write the code for, I don't know, a new page or something, you never have to deal with that at all. Like, so there's like another layer on top that's handling all of that, if that makes sense.
Yep, and I have last one. I was wondering, your platform allows me to share stuff on my page, so I can get embed links.
You're asking about SoundCloud?
Or
sorry, yes, go on.
It's not SoundCloud?
No, sorry, go on. Like maybe I interrupted you, so wrong place.
It's not about Xbox,
okay,
but generally about the web
yes.
platform, because I can get embed links from your application. Are you doing the same on the web, or you're just doing this for the Xbox application?
So we have different web products. So there's like the main website that has garbage collection built in. It actually uses reference counting because that works better with Backbone. But like the one, like there's like an embedded player, that one doesn't have that because it doesn't need it as well. It's really tiny and optimized to load fast and only run for a couple of minutes. Yeah.
Okay. Interesting. So the nightmare for every podcast is when the guest answers with just yes and no. So I have a couple of questions. Please don't just say yeah. So you mentioned Xbox. How it looks like to develop for Xbox? Do they have like a SDK? So make sure, don't say just yes, they have SDK.
It's actually quite fun because you can, like the way this kind of works is like you build your app and then you put it into like a shell, which is kind of like an Electron shell, but it's like the Microsoft equivalent of that. So you can develop on that only in your browser for 75%. And then you have to do the 25% of like integrating with the platform, or probably it's more like 125% integrating with the platform and like figuring out all these bugs that actually happen on that platform. It is kind of tedious because I work on a Mac, so I cannot connect to the Xbox directly. So I have my virtual machine where I have Visual Studio running that is then running like a crazy compiler that is live connecting to the Xbox. And then, but the setup works. So the live reload that like, so you have like your Webpack set up on your Mac and like live reload and everything. And this live reload still works through this entire pipe. So if I change something in my code, and like it will immediately reload on my TV screen on the Xbox as well. I don't know how Microsoft managed to make this all like work.
By saying immediately, is it like 5 seconds or something? Or?
It is. There is a delay. It's not as fast as like, or okay. It's like your local browser, but it's super fast.
Okay. Yeah. So I'll go a little bit meta here. So the React as an ecosystem requires some efforts to integrate it. How did you decide it? I mean, in my head, I imagine how big companies like SoundCloud or I don't know, other companies, they kind of pick wisely what they use for many reasons, for adoption of the developers, maybe some license and stuff. how it was for SoundCloud. I mean, if you have this, or maybe are you actually allowed to talk about this first? I don't want to get you in trouble.
No. Is this recorded?
Yeah, it is. It will be published on the birthday of Rado. So yeah, how did you decide to use React? Is there like this big chain of decisions and meetings with people and yeah?
No. I did this on purpose.
Okay.
No, we didn't have any. So we had React, like I mentioned, we have this backbone application, but we have like a lot of other internal applications, and we have been using React for a very long time, and also different things. Like we had tried out a lot with Ember. We really liked Ember, but we didn't see our future with Ember, so we kind of broke up with Ember and decided for React. Yeah, it was kind of like a polyamorous thing, like Ember and React at some point. And we decided polyamorous is like not
some drama
us.
and stuff.
Yeah.
Yeah. Okay.
And then we just went ahead with the thing that we had the best experiences with, and that was like TypeScript, React, and Redux, because it worked for us really well in mid-sized applications, and we saw people writing about how does it work on a really big application. They're like, yeah, it's fine. So we jumped on this. Yeah.
Okay, awesome. Did you consider moving to Preact or something when this thing with the license happened?
No, at all. No,
Okay.
we didn't. We do use Preact in some other projects, but we have a lawyer team, and we asked them, hey, is this actually a problem? And they looked into it. It's like, no, not at all. Like, we don't know what this fuss is about, and it's fine. Also, if Facebook wants to get into a fight with big companies, I don't think it would be good for them. But I'm not a lawyer, so don't quote me, please.
The favorite answer you get from a lawyer: no. Is this a problem? No. Yeah. One thing we can try, by the way, is to spice up the format. Is there any question from the audience, by the way? Any questions? Okay. He is part of the audience. Oh, risk half. Okay, let's try some real life moving. I mean, it's a moving panel, right? Can you just assist me and pass the microphone?
I was just wondering how often you run the garbage collection, and how do you like decide how often to run it?
Yeah. So we had all these plans to make like the heuristics very smart. And we're like, okay, so periodically we ask the Xbox app, how much memory are you using? But we found this to be very reliable, so it's running like every 5 minutes. But literally, it's an interval, and it's working great.
Okay, cool. Any other questions? Okay.
Hey, yeah, this is a very interesting idea. Have you thought about making it open source?
Yeah.
I understand there are a few things that you probably just gonna hide.
Yeah.
But most of it.
I thought about it and I decided against it because I don't want to maintain an open source project like this, because I can see this getting a lot of like big applications that want to adopt it, and then I would have to answer all their questions, and I don't think I can solve this problem for them and have like a day job at the same time. But if somebody wants to make this an open source application, I will publish a blog post about this, and like hopefully soon. Not for your birthday, but soon.
You didn't say which year. Can be next year birthday. I plan to live for a long time, so you know.
I can make it to next year. It's good.
You hear it first. Okay, I won't run anymore. Any other questions from the panel?
Last one, I promise. Do you do any automated testing on this thing? The integration with the Xbox, and how you do it?
No, nothing that runs on the Xbox, because that would be, because like the integration always works for like a Windows computer on like the Windows command line tools. So we didn't want to get into that trouble. So we have a lot of unit and integration tests that we run in a browser, and we hope it mimics the platform well enough. But like, for example, one thing we would really like to test is you can imagine that a website, you navigate very differently when you can only use a controller. And this is pretty much a website. So there's like some libraries there that integrate with like, how do you focus things? And we would love to test that, but it's not that easy, sadly. Like with a real controller as well. How do you automate input from a real controller, like a real Xbox controller and stuff like that? Yeah.
Robotics, you have a robot which just clicks and do stuff.
We could definitely have like do that ourselves. Like we did that ourselves, right?
Oh, really?
Like yeah, because we don't. I don't know. This thing is just running and it's running very well. So we don't innovate a lot there because we also don't want to introduce new paradigms all the time. So we have like a list of tests that we do manually. Sadly, yeah.
Okay, that's cool. Anybody else wants to mention something? Okay. I don't know. I mean, you can ask. We have time. It's our conference.
Time for one question.
You ask me. Yeah.
No, we have plenty of time.
Yeah.
I actually have one. Okay, go I really like the joke about the lecture in the university that it was 2 hours, but you make it into sweat. And then we have this problem here in Bulgaria. I guess it's not only Bulgaria, that the things that you learn in the university are either like not complete or maybe they are like too old and stuff. So this is something that you probably weren't there in the university and you apply this knowledge in your work here. So is this happening very often to you? Like, do you remember stuff like 10 years ago and you apply them? Like, is it, because for me it's just, nah, it's not happening at all.
Are you asking me if I have if I remember everything that I ever learned in university?
Not everything, but sometimes you remember, hey, I basically learned the bubble sorting in university. I have to like use it now or something.
No, I always look that up. I know that garbage collection existed, so that's what I remembered. But I also never had a lecture actually about this. I don't know if a lecture about garbage collection takes 2 hours, but I imagine it to be actually like 2 days in university more. No, I always look these things up, like on the spot. Like I don't have that knowledge.
And I guess I mean it was nice that you weren't seen or maybe someone teach this to you in university because you know that this thing exists, at least you know that it's there. You don't have to remember it and stuff. But
actually, I didn't learn this in university, so I don't know. I know that like there are languages that implement garbage collection, but before we had this problem, I've never thought about how this would be solved.
Okay. Yeah.
So yeah.
Okay. Nice.
I've been once to a presentation from a SoundCloud engineer, and one thing he mentioned was that you're often running hackathons and you're building internal things that you use, tools. And I remember one thing was called the Bazooka.
Oh, yes.
Does that thing still exist, and what does it do right now?
Yeah, that's very unfortunate naming, and we don't use it anymore. Bazooka was just a command line tool to deploy servers. Like because we don't run things in the cloud, we have like a proper data center and everything, and this is like doing a lot of the automation around all of these tools that manage like nodes. Yeah. I don't know why it was called Bazooka though. It doesn't make any sense.
It was
and
part
also,
of the story.
When like Bazooka finished in the command line, you would get like a big boom. It's like,
you don't want to see that.
No. I hope not, yeah.
Do you want to say something?
No? No.
Okay, quick one, last one. Is there any other cool new tool that you built internally? And like, is this a practice that you still maintain?
Yes, we do that. There's like a concept of like 20% time. Like, for example, me, I work every Friday on something that I want to work on, but also has value for the company. And then, but I'm currently not working on tools. I'm actually organizing a conference.
Cool.
So I can do that at my 20% time.
What's the name of the conference?
Oh, do you want to know? Yeah, okay. This is definitely not scripted. No, it's a conference about the web and audio, and it's going to be in Berlin in September. It's going to be really nice. Yeah, it's going to be a lot of noise, a lot of weird JavaScript noise. It's going to be cool.
We'll get tickets and we'll come.
Yeah, as we see, we like weirdness quite a bit here. And bad structure. Okay, any other questions? So Kras's last favorite thing, no. Okay, time for the next talk.
Cool.
That's